My name is RC Ayala and I'm doing question 2 from the AP Calculus AB 2007 test. So this question states, the amount of water in a storage tank in gallons is modeled by a continuous function on the time interval 0 to 7, where t is measured in hours. In this model, rates are given as follows. The rate at which water enters the tank, f of t, is 100 t squared sine square root of t gallons per hour for 0 to 7. The rate at which water leaves the tank is g of t given by the piecewise function shown. The graphs of f and g, which intersect at t equals 1.617 and t equals 5.076, are shown in the figure above. At the time t equals 0, the amount of water in the tank is 5,000 gallons. Part A of this question asks how many gallons of water enter the tank during the time interval 0 to 7, round to the nearest gallon. The question is only asking for the amount of water entering the tank, which is given by f of t, within the given period. So for now we may disregard the initial amount of water within the tank and function g of t, which gives the rate at which water is leaving the tank. To find the necessary value, we must find the value of the integral from 0 to 7 of f of t dt. Note also that f of t is the rate at which water is going into the tank, not the amount of water within the tank at that time. On your graphing calculator, click the Math button and under the Math tab, scroll down to the tab FNINT. Click this option and plug in the necessary values. The screen should display the following. This is also for the TI-84 Plus calculator, if you are plugging this in on that. Click Enter and the value should be approximately 8,263.8065 gallons. Since the problem asks for us to round to the nearest gallon, the solution will end up being approximately 8,264 gallons. On this particular part, you will gain 1 point for showing the integral and another point for the correct solution, rounded to the nearest gallon. For part B of this question, it states, for 0 to 7, find the time intervals during which the amount of water in the tank is decreasing. Give a reason for each answer. So consider the graph we were provided. Notice that the graphs of f and g intersect at t equals 1.617 and t equals 5.076, which was provided to us at the beginning of the problem. From 0 to 1.617, the graph of f, which displays the rate of which water enters the tank, is below the graph of g, which is the rate at which water is leaving the tank. This is also the case for 3 to 5.076. Since the rate of water leaving the tank, represented by g, is greater than the amount entering the tank, represented by f, the total amount of water in the tank will be decreasing on these intervals. A solution for this problem would be as follows. The amount of water in the tank is decreasing on the intervals 0 is less than or equal to t less than 1.617 and 3 less than t less than 5.076, because on set intervals f of t is less than g of t. You would receive 1 point for having the correct intervals and 1 point for a logical reason. Wait. The f of t must be less than g of t, not equals to. Note that the water is not decreasing at t equals 1.617, 3, and 5.076. Because for t equals 1.617 and 5.076, the amount of water is not changing since f of t equals g of t at those values. T is not decreasing either because g of t is shown to not ever equal 3 according to the piecewise function we were provided. For part C of this question, it asks from 0 to 7, at which time t is the amount of water in the tank greatest? To the nearest gallon, compute the amount of water at this time. Justify your answer. There are two parts to this problem. When is the amount of water in the tank at its greatest level, and what is the amount of water in the tank at the greatest level? So for part 1, we must identify the values on the graph where the net rate of water entering the tank, given as f of t minus g of t, is 0, with the values immediately before that t being positive and immediately following that t being negative. This would create a critical point and also a relative maximum, out of which we can identify an absolute maximum. Just looking at the graph provided, we can see that there's only one value where these conditions apply, which is at t equals 3. With this relative maximum, we must also consider the endpoints, t equals 0 and t equals 7. To identify the absolute maximum among these conditions, we must find what the amount of water would be at those values we've found. Create a table to organize your work with 3 columns labeled, from left to right, t in hours, equation, and answer in gallons. So for t equals 0, the amount of water in the tank is provided to us in our initial condition, which is stated to be 5,000 gallons. So in the equation box, we would put 5,000, and the answer would be 5,000 gallons. For t equals 3, the amount of water in the tank can be found using this following equation. 5,000 plus the integral from 0 to 3 of f of t dt minus 250 times 3. To get this equation, we have found the amount of water in the tank at t equals 3 by taking the integral of f of t from 0 to 3 and subtracting the integral of g of t from 0 to 3, which would also be the same as saying 250 times 3. Then adding our initial condition of t equals 0. The answer should be approximately 5,126.591 gallons, or 5,127 gallons, rounded to the nearest gallon. For t equals 7, the amount of water within the tank is given by this equation. 5,126.591 plus the integral from 3 to 7 of f of t dt minus 2,000 times 4. We can find this equation in a very similar manner as the last equation, finding the integral of f of t from 3 to 7 and subtracting the integral of g of t from 3 to 7, which would also be the same since between 7 and 3 there are only 4 values, so we would do 2,000 times 4 to find the net amount of water that flows into the tank, then adding the initial condition of t equals 3, which we found to be 5,126.591. The answer should approximately be 4,513.807 gallons, or 4,514 rounded to the nearest gallon. With these values, we can determine that the absolute maximum amount of water within the tank at any given time between 0 and 7 is at t equals 3. Part 2 is much simpler to complete since we've found the answer in the last part. At t equals 3, we found the amount of water within the tank to be approximately 5,127 gallons. A sufficient answer for this problem would be as follows. The greatest amount of water that enters the tank is at 3 hours. At 3 hours, the amount of water within this tank is approximately 5,127 gallons. So for this problem, you would receive 5 points. 1 for identifying t equals 3 as a possible candidate using the integrands within those equations. 1 point for that. 1 point for the amount of water at t equals 3. 1 point for the amount of water at t equals 7. And a correct conclusion.